Every app you use today runs on algorithms. Google Maps finding the fastest route, Instagram deciding what posts you see, your banking app verifying transactions. But what exactly is an algorithm? Let's break it down clearly. An algorithm is a step-by-step procedure used to solve a specific problem. It is not programming code. It is not software. It is simply a logical sequence of steps designed to achieve a result. Think about cooking. If you want to make tea, you follow instructions. Boil water, add tea leaves, add sugar, pour into a cup. That ordered list of steps is an algorithm. If you change the order, the result may change. Here's something very important. An algorithm is independent of programming language. Before writing code, developers design the algorithm. For example, problem, add two numbers and display the result. Algorithm, step 1, take the first number. Step 2, take the second number. Step 3, add them together. Step 4, display the sum. Only after defining these steps do we implement them in a language like Python, Java, or C++. So remember this, code is the implementation, the algorithm is the logic behind it.
Now, let's go deeper. For something to qualify as an algorithm, it must follow certain rules. First, it must have a clear beginning. Second, it must have a clear ending. Third, every step must be precise and unambiguous. Fourth, it must solve a specific problem. And finally, it must produce a predictable output for a given input. If the steps are vague, it is not a good algorithm. For example, saying, process the data somehow is not precise enough. Algorithms must be exact.
Now let's look at the kinds of problems algorithms solve. One major category is searching. Searching algorithms help us find specific data inside a collection. Imagine you have a list of 1,000 names and you need to find one name. One simple method is linear search. You check each item one by one. If the list is sorted, you can use binary search, which is much faster. Different algorithms, same goal, different efficiency. The second major category is sorting. Sorting algorithms arrange data in a specific order. For example, arranging numbers from smallest to largest. There are many sorting algorithms: bubble sort, selection sort, insertion sort, merge sort, quick sort. Some are simple but slow. Some are complex but very fast. This brings us to a critical concept: efficiency. Not all algorithms are equal. Two algorithms can solve the same problem, but take very different amounts of time. This is where time complexity comes in. Time complexity measures how the running time of an algorithm grows as the input size increases. For example, if sorting 10 numbers takes 1 second, sorting 1,000 numbers should not take 100 seconds if the algorithm is efficient. Computer scientists use something called Big O notation to describe efficiency. You may hear terms like O of n squared, O of log n. For now, just understand this. Good algorithms scale well as data grows. Bad algorithms become extremely slow. Now think about the real world. When you search something on Google, an algorithm decides which results appear first. When you open Netflix, an algorithm recommends movies based on your history. When you scroll social media, an algorithm decides what you see. Algorithms shape your digital experience every single day. But algorithms are not only about speed, they are also about correctness. An algorithm must produce the right result every time for valid input. If it sometimes fails, it is flawed. In computer science, we evaluate algorithms based on correctness, efficiency, clarity, and scalability. A well-designed algorithm balances all of these. So let's summarize. An algorithm is a step-by-step logical procedure designed to solve a specific problem with clear input and output implemented using programming languages, and evaluated based on efficiency and correctness. It is the foundation of software development. Without algorithms, programming would be random instructions. With algorithms, programming becomes structured problem-solving. And when you truly understand algorithms, you are not just learning to code, you are learning to think logically. And that is the foundation of computer science. If this helped you understand algorithms more clearly, subscribe to Core Computer Science.